Hi everyone, today I'm going to create a video on divided difference, forward difference and backward difference, and I'm also going to be covering Lagrange interpolation in a secondary video. But let's start with divided difference. So each of the difference approximation methods are exactly as they're called. They're a means of approximating value given certain data points. Now, just to understand where this all comes from, the divided difference, let's consider each of these terms A0, A1, A2. So if we have a series of x's and a series of y's. And for each value of x, so let's call it x0, x1, x2, we have a corresponding y0, y1, and y2. What we'll end up doing is we're looking to find out what is the divided difference between these two values. So we want to land up saying, well, what is y1 minus y0 all over x1 minus x0? And that's essentially, if you remember your calculus, this essentially gives you an approximated gradient. So we'll end up doing that, and we'll do that for each term. And this term over here lands up being your A1 over here. The key to this whole thing is when you land up looking at it, when you have your x0, so when x is equal to 0 in this equation, because this equation is just an approximation of this data. When your x is equal to x0, you see that this term over here disappears, this one, and every term after it disappears, leaving only your A0. Your A0 being your y term over here. That right here, let me use a different color, that right here is this term over here. So then let's consider when our x is equal to x1. Well, we land up with this term over here, plus we land up with the next term to the side of it over here. But all the other terms are eliminated because when x is x1, x1 minus x1 is 0, and that exists in all terms consecutively. So we land up with A0 plus the divided difference multiplied by, and you can see that term on the bottom, x minus x0. So this lands up just being A0 plus this term over here multiplied by the denominator, which is y1 minus y0. And given that A0 is y0, we land up with y0 plus y1 minus y0. The y0s will cancel, you'll land up with y1. And as you put more data points in, your approximation becomes more accurate. The nice part about this is what you're essentially creating is, if you've got a series of data points here, here, and here, you're essentially just creating a curve that will do something like that. It'll land up following it, and the more data points you put in, the closer that curve will land up following it. And as you see with 3 data points, you land up with something that's going to be roughly cubic. And that's because each time you add a new term, it's like your Taylor expansion, you're adding we're developing a polynomial. So with that in mind, I'm going to cut this video here, and I'm going to go on to the explanation of how to go through one of the problems.